Hi, this is Energy Right's ZPD house, and I want to show you some of the features and why it makes such a great training tool. It has a number of capabilities. We'll start with an overview in that it gives a 2.5D of a typical house. It looks like a cutaway with a clear plexiglass on the surface of it. It has interstitial cavities, and it can show the communication that happens there. We also have bypass valves. These are located every place you would typically do air sealing. If we were dense packing this slope, you could air seal it to show the effectiveness of that. You also have this. We have an indicator to show when it's air sealed. This shows a balloon frame. If you want to simulate a platform frame, just close it off. We have rim joist air sealing. We have balloon framing, top plate, sill plate, top plate, and sill plate. We have rim joist. We have connection between the garage and the CAS, so we can show a number of different scenarios for garage connection. And we have levers here which operate doors. So all the doors in this house are operable. And by closing this, we can show targeted air sealing strategies. We can show chimney bypasses. We can show ductwork, operable windows, attic venting. We have a control panel here with bathroom, dryer, kitchen, fans. We also have air handler. We have domestic hot water and fireplace indicators, airflow indicators for the flue, and we have a simple power supply here. If we just plug this in here, and it momentarily calibrates, and now I can turn on the fireplace and it shows a steady state condition. If it were firing, it would look like this. We have a miniature blower door here, which if I turn this on, you can see that the draft slows down and starts backdrafting on the fireplace. The more negative the pressure in the house, the faster it backdrafts. We also have the same feature down here with the domestic hot water heater. And so in this we have makeup air vent, we have an air handler, we have a dryer that also can come on a vent. We have an operable miniature blower door which has open, A-ring, and closed positions. And this is hooked up to a DG700. This house also operates with a Retrotec manometer. Now if we want to teach various number of zonal pressure diagnostic strategies, we have a DG500 manometer up here on the left, and we have probes connected to it. So we can reference the outside, or we can change our reference and reference any zone. So if we wanted to stand in the attic room and have that be our reference, as if we were standing there, we would move this over to here. And now on this channel, we would probe into a knee wall, and I could measure the pressure across this zone. So we can do it with bathrooms. We have every room is a zone. We even have interstitial zones that we can check, just like you would in a real house. We also have bathroom fans, kitchen fans. We have ductwork leakage in the garage. Well, we have a number of ways we can simulate different types of house. Obviously, we have a cape style shown in here. However, if we open up the knee walls and close this door, we have a standard two-story house, and this becomes a standard attic simply by closing down the ductwork and the windows. Now we have a walk-up attic that's open, and this is our pressure boundary. Now, because of the many features this house has, it has many configurations, and it allows us to do targeted air sealing, zonal pressure diagnostics. We can do garage connection. and we'll take a look at that a little later. We also have an operable air handler, so with supply and return ducts, and we even have supply and return leaks in the basement. And we see the impact of what happens with duct sealing. We can do pressure balancing of ductwork in each room, and we can also do projected overlay presentations on this house. This is where we take a animated program in Excel or PowerPoint or Flash or Prezi, and we project it onto this house. Let's look at the using the ZPD house for showing garage connection. Simple setup. We have our DG700 set up to blower door. We have a DG7 or DG500 hooked up to the basement and the garage. We turn on the blower door with the basement door open. We're going to run up to -50. This is our reference hose. Here's where we're probing. So across this pressure boundary, we're reading 17 pascals. Now, we can look at this. Ideally, if this is a garage, we want it to be to the outside. Ideally, if I open up the garage door, it would read whatever the blower door reading is. Obviously, I have to bring it up a little bit. However, if the garage is connected to the interior of the house, the more connected it is. Let's look at that. We open the door. We can see that the pressure across this is closer to zero. So if we're standing in this room and probing under the door into the garage, we can see what our pressure difference is. So if the house is at -50, ideally we want the garage to be outside as much as possible. So what can we do to move it more to the outside? Obviously, if this is our pressure boundary here, one of the things we want to do is do some air sealing at the top of this wall. And you can see very quickly that I moved it more to the outside. In fact, one of the things I have to do is actually slow the blower door down, bring it back to 50. And you can see now that we've moved more to the outside. We do air sealing here into the wall. We can see we got connection up through this balloon frame wall. We have ductwork which we close off, and now we've moved it much more to the outside. And that's just one example of how we can do projected overlay presentations to take an abstract concept, make it visual, and help students learn garage connection for zonal pressure diagnostics. Keep in mind the pressures are real, but the CFMs are this big.